Now that we've gained an appreciation of how loads affect an aircraft during its normal operational service, we're now in a position to turn our attention to the study of the aircraft's component parts. We'll begin by studying the structure of the fuselage. After studying this lesson, you'll have been introduced to the following subjects: monocoque structures, semi-monocoque structures, effects of pressurization, the flight deck windows, and finally the passenger cabin windows. The illustration above shows an aircraft's fuselage, highlighted here in yellow. This massive cylindrical structure holds a number of important components. These components are essential to the safe operation of the aircraft. We'll begin by looking at the construction of a typical jet airliner's fuselage. This is normally of a semi-monocoque design. Monocoque derives its name from the French word single shell. In a pure monocoque structure, the skin is responsible for all the loads placed upon it. The shape provides its strength. Unsurprisingly, given its name, eggs are an excellent example of a monocoque structure. However, as transport aircraft became larger with increasing loads, the pure monocoque structure lacked sufficient strength. Thus, a semi-monocoque structure was introduced. A semi-monocoque structure is fitted with additional structural members, known as stringers. These stringers run lengthwise along the fuselage, joining the frames together. This enables the construction of a much more robust assembly. The purpose of the stringers is to provide rigidity to the skin and carry the load along its length. The skin is attached to the frames and stringers by riveting or bonding. Cutouts are made to provide access panels and passenger windows, as illustrated by the image on the right. These are reinforced by doublers or backing plates. To summarise, a jet transport aircraft requires doors and windows and access panels, thus making the purely monocoque design impractical. This is why a semi-monocoque design is preferred.